Hi there, I'm John from CNCKing.com, and today we're going to custom fabricate some corporate awards. For years I've been talking about the synergy that exists between having different CNC machines in one shop. And this is actually a great project to sort of show you what's possible. What you're looking up here is 16 gauge 304 stainless steel. What you see here is 3D printed. And what you see here is CNC routed maple. So we have three different materials working together to produce a final corporate award. Now let's take a look at it from the full angle. So you can see they're blades. They're not sharp. It's 16 gauge and they're curved and they were sanded as well to be a little bit rounded. So again, they're not knives, they're not pointy or anything like that, unless you throw yourself on them. So what you see here to begin with is the maple. And the maple was made the same way as I do my banks over at sandboxranch.com. Basically, I cut the maple into strips. In this case here, it was maple. And I laminate them all with glue. I flatten them with the CNC router and make a perfect sort of slab, because I can't get slabs big enough to do this kind of work. And after the slab is dried and glued and worked out, you end up with a nice base. So let's take a look at that being made right now. When you buy rough sawn lumber, it means that it was just cut by the mill and then right away they sell it. So it is definitely rough on the surface of it. And for me, when I use it here in the shop, it's actually wonderful because it means that you get the full thickness of the material that you wanted. It hasn't been flattened and sort of plain and all the other nice finishing things done by another company. And then you get it and it's a lot smaller. I have more than enough equipment to clean it all up, as you'll see. And that's, for me, produces the best result, the best thickness, the best spec for me, for my customers. In this case here, we're using maple. And the reason we went with maple, there are a couple of other options. Maple had the nice grain to it that you don't get with poplar. It had the hardness that you don't have with fir, or sort of poplar as well. And oak is too dark. So when you do laser engraving, you want a nice, clean surface to work from. And maple just checked all those check boxes perfectly for this specific project here. Now, what you see me doing here with the router is actually doing what another company would have done if you buy your lumber finished at Home Depot or what have you. And that is you're flattening and cleaning up all the surfaces. Now, I have a planer in the shop and I do use it, but I found for glue ups like this here, absolutely nothing beats using the router for it. Now, it's overpriced method of doing it, but the results are really, really clean. You don't end up with snipes in the corners. And although you do waste a bit more material because you're only going as high as the lowest sort of defect in the wood across all the boards, it still produces such a nice result that when I do my glue ups, you can see the seams, of course, because the grain is different, but the seams are airtight. It's absolutely amazing. So I love working with dimensional lumber that I produce myself, because the results that I can produce are better than what you can buy at the store. After that, after everything's nice and clean, now you can see me gluing it up. Now this is very important because it took me about a year of practice making banks for sandboxranch.com to learn how to do this properly. And it looks really, really simple. It's actually quite complicated to get all this stuff working properly. When I do it this way here, I don't have any voids, I don't have any issues with the wood. I've also cut it up. So that means if there are any defects, I know right away, like knots for instance, I know right away where to put those. You want to put them on the edges so they're not in the way. Now for this project here, we ended up with two different colors of maple. And so the more prestigious, if you want to put it that way, had a darker maple and all the other awards had a lighter maple. And it worked out really, really well. When you put the tongue on, that's when you really see the difference. And of course the photography here in the shop and the video just don't do it justice how much of a nice sort of burgundy sort of look that this one had here specifically. You can tell when I flatten it, it's definitely a little bit darker than the one on the far left that you see there. And the one on the far left there is actually the maple that was the lighter color. I just needed something, again, use the maple that has issues with it on the edges because you won't cut into it anyways. And that's what I did. And you can see here the results are really, really nice with it. Now, it takes quite a bit of practice to get even this sort of setup sorted out, because what you're doing is you're switching from bit to bit to bit to bit. I think I had about, I think it was 15 different parameters set up, meaning that, you know, change bit, do a bit of work, change bit, do a bit of work, change bit, do a bit of work, go to another program, do a bit more work. And doing all that needed to be done, because what you have to do is you want to sort of slowly work your way through the wood rather than going into it in big chunks. And the reason for that is because if you go into big chunks, stuff will move on you. You raise some stresses in the wood, you know, a ton of problems you end up having that you never even imagined. And again, I discovered all that stuff when I was making, you know, the banks for my other business. And all that practice really pays dividends when it comes to doing this kind of stuff, because I know what to watch for, because I've gone through all the headaches up to that point. Now, you might be, you know, wondering what happens to all the glue that sort of seeps on the top and the bottom. Doesn't really matter. The router just charges right through it, as you can see here, and produces a really nice, clean surface. Now, I can't do this on both sides at the same time, but there's enough glue that's evenly sort of coming out of all the slices at the bottom so that it is totally flat. I flip it around and I do the same thing again, and you have a completely flat parallel slab that is just wonderful to machine in. And of course, after all that is done, then I went ahead and made all the bases for the banks. Now, I did them in steps because I wanted to avoid, you know, you'd see some sort of small issues in the wood. And so what I did is I knew where they were, so I was working my way around them at every step. So that's why you see me making, I think 3 or 4 in one shot. And then once that's done, I do another 3 or 4, do that one shot and do another 3 or 4, because I was just dodging all these sort of issues with the wood, and it worked out perfectly. I was kind of impressed by that. Now, when you're doing this kind of routery, it takes quite a bit of time to do it properly. There's quite a bit of prototyping involved that you don't see on camera, obviously, to try to get all the settings, all the program feeds, all that stuff working properly. And I'm very, very impressed by the machine that I got to do this with. It's 12,000 pounds. It's a huge machine. The table moves, it's a 5 by 10 foot table, and it moves 10 feet. So that means you need 20 feet for it to move. But the solid gantry, I just can't say enough great things about it. It's just amazing. You don't have harmonics issues. You don't have so many other issues that I had with my previous router. Now, my previous router was amazing, but I was always hitting the limit of what it can do. And this router here, I'm nowhere near hitting the limits of what I can do. As long as you have a sharp bit and so forth. Now, after all that work is done, the next step is to cut it out. I did have a skin at the bottom of it, and that was again to keep it together while I was machining it, but also to avoid having things flying across the shop, which did happen when I made, of course, the banks. That means you got to do a bit more sanding, and for that I'm going through all the grits. So I'm working from 40 grit to 60 to 80 to 120, 150, 220, I believe. Then I work all the way up to 400 on this series here, because I still have to do the laser engraving on them. There's no point having a nice clean surface and then laser engraving, then having to sand it all over again. Something I learned early in my career is always have extras. So it's great to have all these corporate awards finished, ready to go. And I have, of course, an extra here that I could show you for the show and tell part of it. So what you see here is actually with a couple of layers of tung oil, lots of sanding, and laser engraving. But what you can't see is the inside, which is this here. And this is what the 3D print goes into. Now, between the 3D print and this, although it's kind of redundant because it's a perfect fit, it's perfect friction fit, I also put a double-sided tape in the bottom just to make absolutely sure that for some strange reason, if ever it gets loose or the wood expands or what have you, there's still something holding it there into place. Now, the reason why I say it's friction fit is because it's such a tight fit to get it into here that I'm sure that there's a vacuum that develops at least momentarily while it goes down. And if you're just off by like a fraction of a millimeter either way, or a fraction of a degree, it just doesn't go in. So it's going to be the same way coming out. So after the lamination of this is done and they're carved out, as you saw with my CNC router, the next step is to go ahead and start actually laser engraving them. So the nice thing about laser engraving is you're creating contrast in 2 ways if you do it properly. The first one is you're creating charcoal at the bottom and on the edges using the laser, because you're basically using a burning system to create your contrast. And the other way is you're creating depth. And that depth also creates shadows, which creates more contrast. So that's really what I really enjoy about laser engraving wood. And again, that's the advantage of going with a lighter colored wood, because those shadows and that charcoal just come out a lot better because there's more contrast. Now for this award here, 3 of the sides of the bases were laser engraved to the spec of the customer. And then after that, of course, you end up with a lot of smoke and debris and other things on the surface of it. Of course, resins from the wood as well. So that's why I'd have to go through all the grits, not all over again, because I already did most of the finishing work previously. But then you just work your way up until you get final grit, and then you apply tongue oil on all the surfaces except the bottom or the top cavity, which is where the 3D print will end up going. So the nice thing about maple or any hardwood, even softwood to that degree, is that it produces a really nice sharp result when it comes to laser engraving. So this is all laser, there's no paint fill or anything like that. And the reason for that is because you don't want anything that's going to fade, crack, or peel over time. There's still little bits of stuff here because the shop is not totally clean. But what you see here is a bit of a shadow as well. And I like to do that because it really helps show the details. If you don't have it, if you just do a very, very light engraving on this, the problem you end up having is sometimes you sand it off. But the other problem is you're sort of giving away the best feature of laser engraving, that is creating depth. As soon as you have depth, you have shadows, and that's like free contrast on top of what you see here is charcoal. So after this is all done, there's lots of finishing involved. A couple of layers of tongue oil is all I used. I can use some special finishes and so forth, but I'm really a huge fan of tongue oil. It's very hard to screw up. You can put layer upon layer upon layer as long as you're finishing up, cleaning up between the layers. And it's totally food safe. You can eat off of it if you wanted to, not that you'd eat off your corporate award. So after all of this is done here, the next step is to work on the blades. Now because of the finish that we wanted on the edges, that's why we ended up using the laser to do this. The water jet would have been a great solution for this as well. The only reason we didn't use that is because on the edge it's more of a sanded edge, while this is more of a crisp edge. So again, fine little details that you sort of find out by experience. And using the laser to cut this stainless steel, did quick work of it. The other thing I was thinking about using the plasma, but once we added the holes that were where the rods go in through the 3D print to hold everything together, as soon as that happened, right away the plasma was taken out of contention for it, because it would have caused a couple of issues that you don't have to deal with laser, obviously. So as mentioned earlier, the blades are made out of 16 gauge 304 stainless steel, and it's number 4 finish and 2B. It doesn't really matter which kind of finish you end up using for this, because I use my orbital to clean the whole surface up to remove the dross, and by default that creates a nice texture to it, as you can see here. This is one of the extras that will end up going to the recycling, but it gives you an idea of what they look like individually and then as part of the corporate award. Now, the reason why this is fiber laser etched, it's etched right here as well, as you can see, is because if it's fiber laser etched, there's nothing that's going to peel, crack, or fade over time. So it's completely permanent. So basically you have permanent wood engraving, and when you run your fingers over, you can feel it. And you have permanent etching on the steel as well, that again you could feel when you run your fingers over it. So everything so far has been completely permanent on these awards. And the next step after that is actually etching them after they're cut. Now for etching them, it's a little bit more complicated than that because I needed to make a jig. So here's one of the jigs that I made, because I don't have to etch all of the blades, only the first 2 that are facing the person looking at it. So this one and this one, because what's the point of paying me to etch these ones here if you can't really see them? So basically you have a jig. I'm not sure if this is the right, it is the right size. You put it in here. It goes over here. Okay. It'll be tricky getting the right placement on these. So here's basically how that blade would fit in here. And by doing it this way here, I could etch these 1,000 times and be within a fraction of a millimeter anywhere I want for the text to be etched onto the blade. So that's the nice thing about having temporary jigs like that fabricated. So here we are using yet another laser. So on the base, we're using a CO2 laser. When we're cutting out this metal, it's a fiber laser, and it's a high power kilowatt laser. And this one here is a lower powered engraving laser. It's also using a fiber as well. So technically this fiber could cut metal, but it'll take absolutely forever. It's just not designed and created for that. And the reason why we're doing the fiber laser etching is because it's a permanent mark. So whenever we etch the stainless steel, it's going to be on that forever unless you use an angle grinder to remove it. The designer, Waleed, he's the one who did all the 3D prints. He had the machine. Yeah, let him do it. It's great. I was actually very impressed with the final results, the tolerances he was able to maintain. And if you notice, there's little rods going through it. And I was sure he made those after the fact, but he actually made them while he was doing the 3D print. And that blew me away because I did 3D printing. I had a 3D printer about 10 years ago, and I couldn't even imagine doing that kind of stuff with it. So the 3D printing has really evolved tremendously over the past decade, including price. It's incredible how much quality you get out of those machines and how low the price is now compared to what it was 10 years ago. Here you can see me slotting in the rods. So the rods go into the metal, and then the base goes into the wood. And then I had to use a clamp to sort of squish it down a little bit, just to make sure everything was nice and tight, totally at the bottom, which was my biggest concern. Showing you these a little bit out of sequence because multiple things would be happening at the same time. This is a 3D print, and it's a solid piece, very tight tolerances. And the nice thing that the designer came up with the design for the awards. It's not my design. Is you have a rod here. So what happens is you slide in the blade, the stainless steel blade, once it's done being cut, etched, and cleaned up. Slide it in here, and then when you put them all in here, you have an automatic placement for the blades. After that, you slide the rod in, and it locks them into place. This is why the awards are very strong this way, because the blades will not come out because they're held there by the 3D printed rod. And by default, you have the, let me just show it to you here. By default, you have the double-sided tape here. So this fits into this perfectly, and then the blades fit in that perfectly. So you have a very strong award at the end of the day. And you have to keep in mind that you're using multiple machines to create these sort of tolerances. And it's very important to have very good machinery that have the same tolerances. Because if my router was a little bit off, for instance, let's say I made this, half a millimeter off spec, meaning half a millimeter too big, too small, whatever, you notice it in the square or the rectangle here. And as a result, this guy would absolutely not fit into here. And there'd be an absolute nightmare to try to get it to fit. Now, the nice thing about, you can see them all behind me here, is they all fit absolutely perfectly. I couldn't have had a better fit for these. Now, you'll notice that I also used a clamp to sort of pressure them in. And that would be necessary sometimes because when you're routering out a pocket like this here, sometimes you have little micro movements around because of the vibrations of the material and the pressures put into the material and the warping that comes out and so forth. So everything fits perfectly, but sometimes it needs just a little bit of help to get in the perfect fit all the way down to the bottom. And that's why I was using the clamp to press it down. So what are your limitations when it comes to corporate awards? There really aren't any. If you want a corporate award that was big as, my laser here, not a problem. You can make that out of literally any material, titanium through basswood. What you want to do is sort of figure out ahead of time what your budgets are, because that would be your biggest constraint regarding materials, the size of the award, how many awards get done for a certain event, and your timeline, of course. If you say, well, I need these things done in like 2 days, the award will be very different than if you give us a month to do it. Because the more time we have, the more time we have to think about it ahead of time. Now, when it came to making this corporate award here, just to give you an idea of the timeline, it took about a couple of weeks back and forth with the designer to figure out what materials would have worked well, which ones didn't. Originally, we were thinking about actually making the blades out of aluminum, but I wasn't crazy about that. And the main reason was, well, there's two main reasons, I guess. The first one is weight. When you make corporate award, you want something with some weight or gravitas to it. Aluminum doesn't weigh very much. Even, for little blades like this here, just holding it, it's stainless steel. And when you have a whole bunch of them together, it really gives a nice weight to it. The 3D print also adds quite a bit of weight to the overall award. So that means when you give it to somebody, it feels, it feels good. I don't know how else to describe it. The other reason I didn't want to go with aluminum is because aluminum is not a very solid material, meaning it's more corrosive. It's not very corrosive resistant, if that makes sense. And stainless steel is a lot more corrosive resistant. So for durability in my mind, I think, well, I want something that's going to last as long as possible. And stainless steel is hard to beat. There are other materials that are harder, more long lasting and so forth, but this is already overkill as it is. So I was very happy with that. With the wood, we're going back and forth with a bunch of different wood species. We settled on a hardwood, and then it was between oak, maple, and there's some other hardwoods we're considering as well. But we ended up going with maple because it's got a lighter color. And because it's got a lighter color, you can actually get more contrast out of the laser engraving. So there's a lot of things to sort of keep in mind when you go ahead designing an award and then deciding what materials that award would best be shown as. So if you're looking for custom corporate awards, contact me at CNCKing.com. We'll fabricate it, we can help you design it, we fabricate it, and we ship it right to your door.